Hi everybody. Today I'm going to be talking about a new code base that I added to my algorithms repository on GitHub. It's called Hang the DJ after the fourth episode of Black Mirror Season 4. This is just a screenshot of where the repository is and where the code is, and this is the PDF file here that I'm going to be talking about during this video. Um, this These topics really are pretty broad and can veer off into physics, biology, philosophy, and things like that. So I'm gonna try real hard to resist the urge to go down those paths and just focus on what I wrote, what the show is about, and why that is algorithmically substantial. Also, I'm going to try to clarify some misconceptions people have about the episode, some things they missed, and some things they misinterpreted about the algorithms portrayed in the show. Black Mirror is essentially a show about the synthesis of technology, biology, philosophy, physics, and knowledge and reality in general. So it's a very thought-provoking show. It's very exciting for any type of scientist or person who likes to think about philosophy, um, or is just inquisitive about the universe in general. So it's an imaginative look at what we might accomplish in the distant future with uh, very powerful and almost unlimited resources and technology. As the name implies, a lot of times these are very dark pictures of what the future might look like, or dystopian pictures of what the future might be. But sometimes, as is the case with Hang the DJ, there is really nothing morbid about it at all. I found this particular episode to be really happy. It had a happy ending. It was very romantic, I thought. So it was really fun to watch. It was kind of a feel-good episode, and it was really a great showcase of an interesting algorithm. So this particular episode is called Hang the DJ. Uh, the name of the show is, or the name of the episode is because of the song that they play at the end by the Smiths, which is called Hang the DJ. The concept of the show, I will simplify it very much, is it's basically the idea of what Tinder might look like in 500 years. So it's kind of an amalgamation of Tinder and eHarmony. So, obviously Tinder doesn't do like a comparison of two people's qualities and try to match them up. It just shows you their picture and lets you choose them. Whereas eHarmony will take two profiles and compare them. So this kind of mashes up Tinder and eHarmony into this futuristic app where it's going to find you a match. So, this is obviously very interesting to people because, dating is something that's one of the most important things to people because it's one of our purposes in life biologically. And uh, this, I think, it's a very romantic and technologically profound showcase of how technology really could. I mean, this is not a fantasy. This is very serious. Technology really could achieve this type of thing and improve the lives of everybody that uses it. So let's talk about the specifics of what goes on. Actually, before I go on to the outline, I'll just really quick break down actually the way the algorithm in the app works. So in Hang the DJ, there is basically a thing called the system, in which there is a database of users, obviously, and for each person that uses the system, they will take their consciousness and project it into a simulation. So obviously that particular portion of the algorithm is way beyond our current technology. That's why I said, it might be like 200 to 500 years before we get to something like that. Maybe sooner, maybe later, but it definitely will be possible. It's just a matter of time until we have the processing power and the memory capabilities to reproduce the same capabilities of the human brain. So they take the two consciousnesses and they project them into a simulation, and it's the simulation, instead of having a type of a score like this is how well your date went, it's a very intricate simulation which has a binary outcome. So it's a win or a loss. They either escape the system, or they call it rebelling against the system, or they do not. So it's a win or lose situation. Then they take the same, and the whole show is based on one simulation between Frank and Amy. And they take that simulation, they run the simulation 1,000 times, and based on the outcome, based on how many rebellions there were out of all 1,000 simulations, they calculate that compatibility. So as you can see here, Frank and Amy had 998 rebellions out of 1,000. So, as a computer scientist and a mathematician, I thought to myself, how many people would you need in the database to really, in that situation with that type of simulation, how many people would you need with that algorithm to actually achieve consistently that type of result? Because 990, I mean, if you watch the show, it seems like it was kind of difficult for them to escape the system. So 998 rebellions out of 1,000 is very impressive. Um, so I'll really quickly talk about the idea of human compatibility, because I could go on, I could write a book about this, but to put it quickly, human compatibility is very it's stochastic. It's very random. You can't quantify it like some people think you can. Just like, oh, me and this other person have this a lot in common, or maybe you went out on a date and it was a great date. So it's not like that, because there are things in the brain that can make you basically not really or have an adverse reaction to somebody. So an example in the show is the scene where Amy is with another guy who's very handsome and he's a nice guy, but there's this thing that he does after he drinks a glass of water. He makes a funny noise, and based on something as seemingly unimportant as this noise this guy makes when he finishes drinking a glass of water, she really, really, really hates being with him. So that just shows you how kind of fickle the brain is, and how you can introduce intangibles and randomness into an otherwise perfect relationship, and it's not successful. So I just wanted to emphasize that, because I think people watch it, they didn't realize that there was this emphasis on the win-loss over time aspect of the algorithm. So I'm going to get into that right now. So I made this little PDF to remind myself of the different components of computational intelligence that are being showcased here. So computational intelligence is the name of the game here with Hang the DJ. That's basically the area of computer science that we're dealing with. Computational intelligence is a subset of artificial intelligence, where, as you can see, it says it's a set of nature-inspired computational methodologies and approaches to address complex real-world problems to which mathematical or traditional modeling can be useless for a few reasons. The process might be too complex for mathematical reasoning, might contain some uncertainties during the process, or the process might be simply stochastic in nature. So that's exactly what I just said. Like, dating somebody, extremely stochastic, extremely idiosyncratic. You're never going to be able to mathematically define if two people are compatible. Really, the only way to do it is to kind of like they did in the show, run a simulation and then run tons of simulations, because only those simulations include these elements of randomness and things that you couldn't really predict just by looking at the objects themselves. Maybe somebody's clumsy, just a little bit clumsy, and they end up 10 times out of 1,000 simulations tripping and falling, and it made them look silly, or just things that you might even not be able to fathom. The way somebody's earlobe or eye twitches weirds somebody out. It's really just simple little random things like that that can't be predicted, or at least not realistically. So as they put here, too complex for mathematical reasoning or modeling. So the second bullet point is the infinite monkey theorem. The infinite monkey theorem is simply a metaphor for the fact that over a given in a long enough period of time, anything that can happen will happen. So the monkey at the typewriter is just a metaphor for a random sequence of letters and symbols, and the metaphor states that given an infinite amount of time, just randomly generating characters will eventually, deterministically, it will produce the complete works of Shakespeare. Uh, it does note that even producing Hamlet alone would be more improbable than the existence of the current universe. So it 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 would take an amount of time that is unfathomable to anybody or anything, but it would happen eventually. And this again, like I said, I'm not going to go off on tangents about philosophy or ontology or metaphysics or anything like that because um, this is like the debate you get into with people who kind of don't have the either the mathematical or basically the science background in order to understand uh, models like evolution or natural selection, where it really takes an infinite amount of time or a very unfathomable amounts of time for things to be successful. So, a lot of people will look at the Earth, for example, and say, "Oh my God, there's just no way that this could have happened randomly," which kind of leads to the third bullet point, which is the anthropic principle. This is a single case of the infinite monkey theorem, where the existence of our current of life in the current universe is actually totally unremarkable. So the probability of it happening is in total harmony with the amount of time that's existed in the universe. So basically, not only is it not unbelievable that all the properties and parameters in order for life to exist lined up at one point in the unfathomably massive universe. Not only is it like not impressive or improbable. It's inevitable and it's very it's unremarkable. It's like, well, of course, with a thing that size existing for 5 billion years, that is going to happen. So this is all about probability over time, which is important with the Hang the DJ algorithm, because without running 1,000 simulations on tons of people in the database, you're never going to be able to boast of that 99.8% compatibility rating that the system can produce. So these types of algorithms only work over large amounts of time. And that's, you're going to have people who can't comprehend infinity or things happening over an infinite amount of time. And, those are the people that are not going to understand these algorithms and the things that they produce. And this isn't fiction. This is, this is something that happened, right? This is something that uh, the universe does exist and life does exist on the planet Earth. So, that uh, all life on Earth evolved from single-celled organisms, and you can research that in evolution yourself. So what I've been talking about here is basically evolutionary algorithms and genetic algorithms that use mechanisms inspired by biological evolution, such as reproduction, mutation, recombination. In this case, what we're interested in is selection. Selection. So back to the outline here. This is kind of a big point that I think a lot of people missed when they watch Hang the DJ, and that's the success heuristic. So things like eHarmony, right, are score-based success heuristics. They're basically similarity searches. So, in eHarmony, they're like, oh, we have 29 dimensions of compatibility, blah, blah, blah. We're going to find you the perfect person. Well, that's really for a computer scientist, this is very laughable because 29 dimensions of compatibility is really not going to tell you anything. So basically what they're doing is they're saying, you guys have the same politics, you guys both are non-smokers, you guys are both, you both like dogs. And while those things are interesting and definitely not harmful, uh, those aren't going to be the things that make or break whether or not you are successful as a couple. It's, I mean, I'm not trying to like be sound like I know everything, but the simple fact of the matter is that interpersonal relationships, the meeting of two unbelievably complex things like human beings are, like I said, extremely stochastic in nature. So much of the interaction is based on randomness and things that you cannot quantify or predict easily. That's why, comparing the similarity of two people is very unhelpful in, it's not harmful, but it's not really helpful in determining whether or not they're going to be compatible. So I don't care if it was, 1,000 dimensions of compatibility. It's still going to be, like not really very impressive to me. So, the difference here in Hang the DJ is they used a goal-based heuristic. And I've been talking about evolutionary algorithms, and the reason is because natural selection is a perfect example of a goal-based heuristic, and a perfect example of why, and not just why, but how it was more successful. So the game in Hang the DJ is not whether or not you got an A or a B or a C or a D or how well you did. You could say like, oh, they could have used a score-based heuristic and Hang the DJ. They could have scored every date, added up all of the scores, and then just took the average and then set you up with the person who had the highest average score. And you might think that that's the same algorithm, but it's really not. And the reason that it's not is because think about natural selection. Natural selection basically killed off all of the species that couldn't survive. It wasn't based on, who was the smartest, who was the fastest, who was the strongest. It was based on one thing and one thing only, and that's who won and who lost. And the reason that's so important is because it includes all of the things that are random and stochastic and intangible, in addition to all of the qualities of the the object itself. So by making it by prioritizing the goal as the end all be all thing that matters, we don't give any points for almost, right? So that is of the utmost importance in this algorithm, and that's the reason that most people didn't kind of get their mind blown by this. This is an algorithm inspired by natural selection. It's a game where you win or you lose, and it kills off all the losers. And if you, in order to be the person who is highly compatible with the person doing the query in the database, you have to win the game almost every time, and that's so improbable that the in order for them to have good results, they're going to need a ton of people in this app. So I went on to start thinking about that. And so the only thing I have left here is time complexity. So this is an order n squared algorithm. What that means is this red line over here, the computational complexity that measures or estimates the time taken for running an algorithm. So since Hang the DJ, or the system in Hang the DJ, is an n squared algorithm, the more people that are in the database, the amount of time it's going to take to run these simulations is going to increase exponentially. And I have the math that demonstrates that. So keep that in mind. It's an n squared algorithm. It's going to take a ton of time the more people we have. But at the same time, we've just said that the algorithm that we have is really only useful if we can run it over a lot of time. At the very top here, I wrote, infinity, probability, and time. This is, this kind of system like natural selection, or the system in Hang the DJ, when you're saying, yeah, you might have been great, but you didn't win the game, so too bad, right? It's very, very punishment oriented. You have to win the entire game or else you do not reap the reward. So given that you need an immense amount of time to produce results and success. So that's why these, like natural selection, the goal-based heuristic in the system of Hang the DJ is very good and will produce amazing results, but also takes a lot of resources. It takes a lot of time, and it takes a lot of samples. So time complexity, it's an n-squared algorithm, like I said. So an example of this is just, given 10 accounts, 1,000 simulations per account. So you saw at the end of the episode, Frank and Amy ran 1,000 simulations together and somehow managed to rebel against the system 998 times. But, don't forget that Frank was just a guy Frank and Amy were just people who were running their profile against every other profile in the system. So actually, for Frank to do his query, he didn't just have to do 1,000 simulations with Amy. He did 1,000 simulations with every other person in the database as well. So even if there were only 10 accounts and Frank and Amy were in there and they were doing 1,000 simulations per account, that would be, just for Frank, 10,000 simulations. And then if you thought from the company who owns the system's perspective, whoever wrote the app, they would have to perform 100,000 simulations because there's 10 people doing 10,000 simulations. So 100,000 total simulations. So to kind of showcase the exponential time complexity of this algorithm, given a million accounts, which is not that many, as you can see, in 2014, Tinder had 50 million users. So a million accounts is really not that many, especially in the distant future. It could be a ton more than that. But look at this: just given 1 million accounts at 1,000 simulations per account, even just Frank alone saying, "Hey, give me my matches," requires 1 billion simulations. And for the company to support a million accounts, all doing queries, they need to run 1 quadrillion total simulations. So, I mean, that's just with a million accounts. As that gets bigger, it's going to be, exponentially and almost incomprehensibly bigger. So this is a powerful but very expensive algorithm. So the other thing that I wanted to show you was my code. So I will start by saying that the actual simulation part of it, this is obviously beyond our current technology. I'm not going to pretend that I wrote some code that projects, all the states of all the neurons in the brain and all the synaptic weights so that I can project the data that represents a human consciousness and its tendencies and predicting what it will do in response to different external stimuli. So I'm not going to pretend that I can do that, but I did everything else. So that part is hard, but the rest of it is easy. So I have, this, obviously the main program is just create the database, create Frank's account, run the query, find my best match, and print the results. It's as simple as it can be. To explain what I did to substitute for the actual simulation, I just want to point out that it doesn't matter, because since I've already conceded that I cannot do this, right? We just don't have the technology yet to figure out what what we need to. Well, basically, I know what I need to do. I need to know the state of the brain. But that's so much information that I can't possibly store it all. So if I had every single piece of information about somebody's brain, two people's brains, and then also all the information about the environment that they're in, I could do it. But obviously, that's like I said, hundreds of years off, probably, maybe more. So what I've done is I've substituted just a simple algorithm that doesn't really even, this doesn't really matter how I do this. I just wanted to randomly give certain people kind of a semblance of compatibility with other people so that they would do, they might do better in the game than other people. So this is going to, for each person in the database, just kind of make them a random performance. Some people will be very bad at attempting the simulations, and some people will be very good at it. The lucky people will have a much better chance than the unlucky people, but even the lucky people are bound by their quality and might roll a bad random number. So that's kind of that part, and then the only part left really is the account database. This, you put in the number of accounts and the number of simulations, and I'm not going to go through every line of code, but it's pretty clear that it's so simple. It's just a couple of for loops. You just create however many accounts you have, and then to do a single query, you match your account against every other account, and for each one of those matches, you run 1,000 simulations, count the number of rebellions, return the account that had the highest number of rebellions, as well as the account itself, and then the query result is the class that basically prints out the results. So I guess there's really nothing else to show except running the program based on how many accounts there are. So I have 100,000 accounts there with 1,000 simulations. So this is going to do like 10 million simulations rather quickly. And with this number of accounts and this number of simulations, it really is going to find like somebody with a 99.5% compatibility every time, because there's so many users. In this case, I'm printing out the luck and the quality of the person who did the best. So account number 59,515 had a luck of 100, quality of 100. So they're kind of the perfect person. And since they were so amazing, they were able to rebel 995 times. So, like I said, it doesn't really matter how we represent the quality of the person at this point in time, since it's all synthetic anyway. However, what does matter is if I change the number of counts down to 1,000 instead of 10,000 or 100,000, you're going to see all of a sudden, wow, I got actually, it's not that lucky out of 1,000, but it's pretty lucky out of 1,000 to get somebody with 100 luck and 100 quality. But you're going to see, start getting some less results with 1,000 accounts. I mean, 1,000 accounts is still a lot. The best person, the best person that I found in this case out of 1,000 accounts was very lucky and also high quality. So they were able to rebel 951 times. Not as good, but you're going to see some results that are less. So this one's a 92% compatibility, 929 rebellions. Here's one that's only 744 rebellions. So 1,000 accounts is not bad, but if we put this down to 100 accounts, even staying with 1,000 simulations, we're going to start seeing some bad results. So, here was only 533 rebellions out of 1,000. Here's 484, 507, 523. I got really lucky there. Even with only 100 accounts, there was somebody who was able to be a good match randomly. So that's pretty much it. I just wanted to kind of show that the logic behind this algorithm is easy to code, but it has huge implications on the future of how we could potentially implement not just dating apps, but any type of heuristic apps. This is, like I said, natural selection is another kind of use case of this. You could, theoretically, if you could simulate these types of situations, you could also simulate the survivability of certain types of life forms in certain environments. So I promised I wasn't going to go down tangents, so I'm not going to say any more about that, but I hope that's enough to get your mind going a little bit. This is for my technically for my algorithms class, but I asked everybody in my classes to look at this, and so I hope that at the very least you might want to start watching Black Mirror if you're interested in technology and kind of somewhat fantastical, but definitely creative and imaginative pictures of what the future might look like. It's really good, and also, it's not just that show, but a lot of things that you see in life can inspire you to not just replicate, but hopefully invent and innovate in technology. So there is kind of this synthesis of knowledge and science happening where everything is related. Like I said, physics, biology, philosophy, technology. So you should probably, you can always be inspired in thinking about these types of things to help you grow as both a programmer, a person, a scholar, and it definitely makes a better programmer to be always thinking about things like this, because it boils down to solutions to problems. That's the bottom line. So I hope this was not too tedious, and I am going to be doing some more algorithm videos in the future, in the near future, because of my algorithms class, but there's also some other stuff that I've been working on too that I want to do. So we'll see what the future holds for me, and I will talk to you guys soon. Bye.